Hello everyone, welcome to day 10. We'll continue with the array medium questions. Next is 2sum. The question is, given an array of integers and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. Okay, so basically we have to find two numbers in the array in such a way that when we add up both the numbers, it should come up to this value, the target value. For this, the brute force approach would be that we find all the pairs in this array. We make all the pairs in the array and find the sum and see if it is equal to array, if it is equal to target. That will take n square time complexity. The other way of doing this would be that we find an element and then we find we see this is the first element, right? So we see 2. Now we will search the difference of 2 and 9 in this remaining array. So what we can do is we'll do 9 minus 2 is 7, and then we have 2, so we will find 7 in the array. If it is present, then that is the answer. Similarly, if we have 7, then we'll find 2. We have 11, then we will find minus 3, minus 2. We have 15, and we'll find minus 6, and so on. So in this way, again it will take n square time complexity for searching as well, because we have to go through the whole array. Other than this, what we can do is initially we can put all the elements in a set, and then we'll start iterating over this array, and we can check the set if the difference of both of them is present or not. But that is one way of doing this, but it is not the optimal solution, or it could be the optimal solution, but the issue is that we won't have the indices. We want to return the indices, so we'll have to use a map. And instead of putting all the elements beforehand, what we can do is, while iterating, we can put the elements. So let's say we have we'll create a map of integer values. Integer map equals to hash map. Okay, and then we'll start iterating over this array. I is less than nums dot gth, and then we'll check if we'll find the difference. So int diff equals to 0. We'll find the difference. So diff equals to target minus nums I. We find the difference. Now we can check if map contains diff. That means we can make target. If map is having diff, then what we can do, we can return a new array. Return new array. Can we initialize the array like this, I, and the second variable will be m dot get value get diff, diff here, or otherwise we will put it in the map. So map dot put, and this value diff nums I comma I. Or should we put diff in this? If we put diff in this, then no, I think this should be fine. New. Map dot contains is not a thing. Map dot contains in Java contains key. Okay, contains key. At the end, return the answer in a. If you assume that each input would have exactly one solution, you may not use the same element twice. Return or what shall we do? Done. Okay, we'll move to next question. Sort colors. This is a medium question. Okay, given an array nums with n objects colored red, white or blue, sort them in place so that objects of same color are adjacent and the colors with the colors in order red, white, blue. We will use the integers 0, 1, 2 to represent the colors respectively. You must solve the problem without using library sort function. Okay. Okay. So to do this question, what we can do is, if these numbers you see 1, 0, 1, 2, these are fixed, we can have only 3 values. So the easiest way of doing this would be that we take 3 variables, int 0, 1 and 2. We'll take 3 variables. These will be the count of or frequency of these digits. Then we'll iterate over this array. Or we can do for int if num is 0, then we'll do 0, 0 plus plus. Else if num is 1, then we'll do 1 plus plus. Else we'll do 2 plus plus. So basically what we are doing here is we are counting the frequency of each digit, and then we'll iterate again over this array int n nums dot length, and now we will check if 0 is present. If 0 is not equals to 0, then we will make nums I equals to 0 and 0 minus minus. Else if 1 is not equals to 0, we'll make nums I equals to 1 and 1 minus minus. Else we'll do nums I equals to 2 and 2 minus minus. This is working fine. Submit it. But why is this a medium question? It worked. Okay. Why it's a medium question? I don't think it should be given a... Am I missing something? You must solve the problem without using library sort. We are not using library. This is kind of counting sort. Given an array nums with an objects colored red, white. Let's see the hint. Iterate the array count number of zeros, overwrite array with total. This is what I've done. Then what? Is it fine? You must solve this problem without using follow-up. Could you come up with one pass algorithm using only constant extra space? This is 2 pass, right? First we are counting and then we are again iterating and filling the array. So this is 2 pass algorithm. They are expecting a 1 pass solution for this. I think something similar to 2 pointer can be done using 3 pointers in this. Not sure how we can do it. Let's see. If we can have 3 pointers like 0, 1 and 2, then somehow if we try to we maintain the gap and fill the window with zeros, ones and twos. Let's see. So this is the array, right? Now if we take 3 pointers, because we want 2 partitions in this array. 1 partition will contain 3 partitions. One will contain 0, then next partition will contain 1, then next will contain 2. So we will require 3 pointers to add the break between them. So let's say 0 is the partition. We can keep 2 at the end because we want 2's at the last. We keep 0's at the start and 1's at the middle. Okay. Middle where? Let's say 1 is also at the start. So what will happen? And 2 is at the last index. Now, whenever we will find a 2, whenever we at the front, we can swap it with the this last one, right? And decrement the 2 variable to come forward, because this is now fixed. This 2 is fixed. Similarly, whenever we find a 0, we will add the 0, swap the 0 to the front element and increment 0. And whenever we find a 1, then we can simply move forward, because 1 is in the middle and that is the correct position of it. I think this should work. Let me try to write it. So we have 3 variables, okay. 0 will be at starting index, 1 at starting, and 2 will be at the end index, which will be, let me take one more variable, n equals to nums.length. Okay, and 2 will be last index, so n minus 1. Now what we can do is, while our 1 will iterate 1, and while 1 is less than n, what we'll do, we'll check if nums of 1 is 2, that means 2 is at the front. Then what we can do, if it is 2, then we'll swap it. So let's take a temporary variable as well to swap. Okay, so in this case, temp equals to nums 1 equals to nums 2, right, and nums 2 equals to temp. So by this, what we have done is we have swapped this with the last element, and then we will decrease the last pointer, so 2 minus minus, because now we already have 2 at the last index, so we will decrement it. Else, if now what if nums is 0, nums 1 is 0, in such cases again we can swap, because it is 0, so we can move forward leaving it. So we can similarly do this thing, but instead of swapping it with 1, we can swap it with 2. Nums 0 equals to nums 1. One second, I'm getting a call. Temp nums 0 is nums 1 and nums 1 is temp. And now in this case we can increment 1 as well as increment 0, right, because we have already found 1 and we have already found the 0, so we can increment that, and we have to increment 1 also. Else, last case is when it is 1. Now when it is 1, then it is at correct position, right? 1 is at correct position, it is at the middle, so we can simply increment 1. I think this should work. Nothing to return. This should work. What is happening? So 0 to 1, it is doing 0 to 1 instead of 0 1 2. Am I missing something? 1 should be less than 1 can be less than equals to 2, right? Let's see. Okay, submit. It worked. Okay. Next is majority element. Given an array nums of size n, return the majority element. The majority element is the element that appears more than n by 2 times. You may assume that the majority element always exists in the array. Okay. So initially, brute force approach would be, um, we can, if we want to do it in linear time, then we can take a hash map, count the frequency of each element, and then we can return the max frequency element. Also, what we can do is, if we can sort this array, and the middle element will be the result, because if the number of elements is more than n by 2, then max element will be at the middle as well. mm, Other than this, I think sorting one is a good approach. But there is again a follow up. Could you solve the problem in linear time and order of one space? We can solve it in linear time if, similar to last question, if there were only 3 or 4 variables, integers, but these could be anything, right? So if we start iterating over this array, uh, we have to do it linear time and order of one space. Order of one means no hash map, no set, no nothing. Can we do something in terms of taking bit, doing some bit manipulation? Because in earlier questions we saw that taking XOR of number with itself gives 0. So if we are doing XOR of maximum numbers, it will be 0, and then will be left with something. mm, 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 mm. What if I take XOR of all the numbers, but again the result will not give us anything? Sorting, but linear time is required, so no sorting, no hash map, no set. mm, it is showing it's a easy problem, but how come it's a easy problem when linear? I'm not able to think of any such solution where it can be done in linear time. There are no hints. Let's see the discussion. Have a good day. Keyword. Have a good keyword. Boy. Okay, there is some algorithm, majority vote algorithm they are using. I'm not aware of this. Other good solution to fit the requirement is to use bit manipulation. Bit manipulation is also one of the solutions. Okay. Mm, Let's see what is this Morse voting algorithm. Okay. And this is an easy level question, but it is very important. It can easily be solved with 2 or 3 techniques, but the main algorithm that we'll learn is this one. Approach nested for loop. We'll take 2 for loops. Then sorting algorithm, then hash map, then this last one. And they haven't provided the explanation. Have they provided this here? I think this is the one. Brute force map. This, in its most basic form, the algorithm seeks out a majority element if one exists. A majority element is one that appears more than half of the times in the input elements. However, if there is no majority, the algorithm will not recognize this and will continue to output one of the items. Algorithm is divided into 2 parts. A first pass identifies an element as a majority, and second pass confirms the element identified in the first pass is indeed a majority. The method will not identify the majority element if it does not exist, and thus returns an arbitrary element. Okay. Begin by initializing 2 variables, num and counter count, both set to 0. Now we will begin iterating over the number, and for each element x we check to see if the count is 0, then we will assign num to x. Then we check if to see if the current num is equal to x. If not, we decrease the count by 1, else we increment it by 1. Reset the count to 0. Find the frequency of num variable by looping through the nums array. Now if the count is okay, what is here? Initialize 2 variables, count an element to track the element being counted, traverse through the given array. If count is 0, store the current value of the array in the element. If count is 0, store the current value. If the current element in the array is same as element, increment the count by 1. If the current element is different, decrement the count by 1. At the end of traversal, the integer stored in element will be the expected result. अच्छा, सो इन फर्स्ट पास हम क्या करेंगे कि यहाँ पे 2 है तो हम 2 रख देंगे यहाँ पे और काउंट को इंक्रीमेंट कर देंगे. देन अगेन 2 है तो हम काउंट को इंक्रीमेंट करेंगे. 1 है तो हम काउंट को डिक्रीमेंट करेंगे. अगेन 1 है, हम काउंट को डिक्रीमेंट करेंगे. अगेन 1 है और यहाँ पे 0 है तो हम एलिमेंट को चेंज करेंगे और काउंट को इंक्रीमेंट करेंगे. फिर क्या है, हमारे पास 2 है, इंक्रीमेंट करेंगे. अब हमारे पास 2 है तो हम काउंट को डिक्रीमेंट करेंगे. काउंट 0 आएगा, ये गलत लिखा हुआ है. और फिर वापस से 2 मिलेगा तो हम, हाँ ये वाला आ जाएगा ना, वापस से 2 मिलेगा. ये 2 पास क्यों कर रहे हैं? आई थिंक आई गॉट इट. There's something wrong in their explanation, but I think I got it, what they're trying to say. It is called Moore's algorithm. So whenever we find the same value which is present in the element, we'll just increment it. If it's a different value, we'll decrement it, and if the count is 0, then we'll change the element and then increment it. Right, let's try to write it down. So we'll take a count, we'll take a value, we'll start iterating for int I equals to 0, I is less than nums dot length I plus plus. Now we can check if but what if value is all actually 0, then it will not work now, because what if value which we are pointing here is actually 0. So let's do one thing. Initially nums cannot be 0, right? Length of should be 1, so value should be nums 0. फर्स्ट एलिमेंट को दे देते हैं और काउंट को 1 रखते हैं, एंड देन विल स्टार्ट इटरेटिंग फ्रॉम 1. ठीक है, and then we'll check if num size equals to value, then we will increment count. Else if nums I else अब equal नहीं है तो क्या करेंगे, हम चेक करेंगे if count equals to 0, then हम क्या करेंगे, val equals to nums I and count plus plus. Else हम count माइनस माइनस करेंगे and return value. I think this should be the solution. Done. I'm good for today. We'll continue tomorrow.